In this video, I am going to discuss about the Schotten Baumann reaction. Schotten Baumann reaction is the reaction between the amines and the acid chlorides to give the amides. So let us write the general equation here, the acid chloride. So this is the acid chloride reacts with the amines. This is an amine, and the reaction takes place in the presence of a base, that is a base catalyzed reaction, and the solvents that are used are generally ether or the dichloromethane can also be used, and the product in the reaction is an amide, and HCl is the byproduct. So chlorine from the acid chloride and this hydrogen will be removed as the hydrochloride. So here the base is added in the reaction because the HCl that has formed in the reaction will be neutralized by the sodium hydroxide. So if the base is not added, the reaction will not be moved in the forward direction to give the amide. So the yields will be less. So if you don't use sodium hydroxide, the yields will be less because the unreacted amine, so the amine that has been unreacted, will react with the HCl and this will form the amine hydrochloride. This will form the amine hydrochloride. So this amine hydrochloride cannot react with the acid chloride, and therefore this has to be neutralized with the base to give back the free amine. And this is the free amine that reacts with the acid chloride to give the amide. And so in general, Schotten Baumann reaction uses the aqueous sodium hydroxide as the base. So the use of biphasic sodium hydroxide is named as the Schotten Baumann reaction. So both the Schotten Baumann reaction can be done both on the alcohols and amines. It can be done both on the alcohols and amines. So let us write an example with an amine. So this is an amine, and if it reacts with the acid chloride, so with sodium hydroxide and solvent ether, then we are going to get the amide as the product. Amide as the product. So in the place of amine, if we take aniline, this is aniline, and if you react it with, in the place of acid chloride, we will take benzoyl chloride. This is benzoyl chloride. So what we are going to get, this is the amide. NH C double bond O and C6H5. So this is called as benzanilide, or this is also called as N-benzoyl aniline. N-benzoyl aniline. So this total group is called as the benzoyl, and benzoyl attached to aniline, that is N-benzoyl aniline. So let us write the same equation with the alcohols. So with alcohols, we get esters as the product. So if you take an alcohol and treat it with any acid chloride and base, we get so this is the ester that is going to get with the alcohols. And so now let us write the mechanism of the reaction. Mechanism of the reaction. So this is the acid chloride and reacting with an amine. So on the nitrogen we have lone pair of electrons. So in any reaction, always the electron rich species will give the electrons to the electron poor species, and these lone pair of electrons will attack on the electron deficient carbon, and we get a tetrahedral intermediate. So this lone pair will attack on the electron deficient electrophilic carbon. These pi electrons move on to the oxygen, and we get the tetrahedral intermediate. Since the pi electrons are moved on to the oxygen, we get a negative charge on the oxygen, and a CN bond is formed between, this is the bond between carbon and the nitrogen. The CN bond is formed, and the intermediate. Since nitrogen loses the lone pairs, we have a positive charge on the nitrogen and a negative charge on the oxygen. In the next step, the electrons are moved back to the form the carbonyl, and this chlorine is lost. So we get R C double bond O N, and we have a positive charge on the nitrogen and R. So on this, the chloride ion which is there will pick up the proton, and we get the amide. And R. So to differentiate, we put R prime over here, and this is the amide.